Good afternoon and welcome back to the Cutting Edge stage on day one of CogX 2020. My name is Anushka Sharma. I'm the founder of Naught and I'm here to take you through today's proceedings. Make sure that you join the conversation online with us with the hashtag CogX 2020. Let your friends know about what you're learning here. The Cutting Edge stage is the place where we're looking at technology that technologists and academics and entrepreneurs and institutions are leading on over the next 12 to 18 months. And it's really to allow you as attendees to understand where that might fit into your strategy over the next 5 to 10 years. So I'm really delighted to introduce the next session, which is exploring the interplay between artificial intelligence and collective intelligence. I'm going to hand over to our host for the next session. It's Ravi Gurumurthy, who's the Chief Executive of Nesta. Over to you, Ravi.
Thank you very much, Anushka. As Anushka said, today's session is really focusing on the interplay between artificial intelligence and collective intelligence, how humans work together in teams. And when you think about the different narratives about AI, they often paint AI either as a savior that's going to do heroic things that we could never possibly dream of, or as a villain that's going to destroy jobs and human input. We also think of AI also as a given, technology that's going to just happen to us rather than a technology that we can shape for the good. So today what we're going to do is explore alternative future visions of AI, focus instead on how technology can help make the best use of collective human intelligence to address social challenges, whether that's dealing with COVID or healthcare or agriculture or even human rights. And with us today to talk about these things, we have four fantastic speakers and participants. First of all, from my own organization, Nesta, Dr. Berditchevskaia, who is the researcher on AI and collective intelligence at Nesta's Center for Collective Intelligence Design. We also have Yvonne McDermott Rees, who's a professor of law at the Hillary Rodham Clinton School of Law at Swansea University. And her expertise is in the law of evidence, international criminal law, and human rights law. And we have Dr. Dharani Burra, who's a data scientist with Pulse Lab, who's joining us from Jakarta. And that Pulse Lab is a data innovation facility between the government of Indonesia and the United Nations Global Pulse Program. And he's responsible for managing projects related to digital agri-food systems. And then finally, we have Dr. Rosenberg, who is the CEO and chief scientist of Unanimous AI, a Californian company focused on amplifying human intelligence using AI algorithms modeled on natural swarms. So with that, I'm going to hand over to Alex, who is going to talk a little bit about how AI is already helping to enhance and scale collective intelligence.
Thanks, Ravi. I'm going to assume that you can see my slides and go ahead and get started. So I'm starting by talking about a company that maybe some of you have heard of. It's called Blue Dot, and it was one of the first to identify the emerging risk from COVID-19 in December. It's one of a host of AI systems that help to identify signal in the noise of unstructured human collective intelligence. It uses natural language processing and machine learning in order to parse through diffuse, distributed human contributions, such as news reports or notices from expert networks like ProMed and WHO, and combines this with novel data sources like airline traffic data in order to generate an early warning to its clients about the spread of infectious disease. And of course, in these contexts, timing is everything. So that's not the only part of the story, though. We're also really interested in what happens after that early warning signal. So it's really important to think about the interpretation of those signals. And that's where networks of experts such as policymakers, infectious disease experts, medical professionals, and even citizens come in to help us respond and manage an emergency. And it's this active collective intelligence that's also a very important part of the puzzle when dealing with big global problems. And so today's session is really going to focus on how we can make the most of both human and machine intelligence in order to address challenges. But what exactly is collective intelligence? It's an old idea. It's been around for a long time, and traditionally it refers to how people think and act together in groups to solve tasks or problems. And what emerges is often more than the sum of its parts. So one of my favorite examples is the crowdsourcing of the first edition of the Oxford English Dictionary, which took over 70 years in total to collect 415,000 words. And it sounds funny because now when we think of a modern equivalent, such as Wikipedia, there are more than 6 million pages created each month. And of course, the difference is that with 21st century collective intelligence, we have digital technologies that are allowing us to connect ideas and insights from people with novel data sources at a scale and speed that has never been possible before. And so we've seen the proliferation of methods that take advantage of these distributed inputs, those that aggregate and combine independent contributions from many people, such as crowd predictions, and even those that are more interdependent and depend on deliberative processes or problem solving in real time, such as decision making platforms for digital democracy or peer learning networks. And AI is a vital part of the toolbox that's helping us to turbocharge collective intelligence. And when it comes to solving complex problems, it's really important that we have both human and machine intelligence because they bring different strengths and weaknesses to the table. So human intelligence is very flexible and it allows us to apply contextual judgment. On the other hand, AI is incredibly consistent and manages to process vast amounts of information at incredible speed. But it gets stuck in its ways, which means that when there's a dynamically shifting global problem, which is often the case in complex problems, then it struggles to adapt. And that's why we need to figure out what are the complementary mixes of both human and machine intelligence if we want to address different parts of these bigger problems. That's exactly what our research at the Center for Collective Intelligence Design is concerned with. How can we design systems that make the most of both human and collective human and machine intelligence? We published a report earlier this year, which was an analysis of existing case studies that looked at collective intelligence methods ranging from crowd mapping to citizen science, and saw how AI was already being used in their context and having techniques such as natural language processing or computer vision and autonomous systems applied in those contexts. So the first type of interaction that we found, and there are 4 in total, but of course this is a kind of emerging framework, was like the early warning systems that I described at the beginning. So it's where we have AI help us to make sense of and give structure to distributed, passively generated human knowledge and other data sources. In the second type of interaction, we have distributed microtasking performed by a crowd on a particular task. And we saw examples of AI being deployed alongside the crowds in order to perform the same tasks. And in these contexts, it was interesting because there was often a feedback mechanism, which meant that over time, the crowd could monitor and continuously improve the performance of the AI algorithm. The third type of interaction is the most elusive at the moment in the real world. So it's all about how AI agents can form part of a closed loop system with groups of people in order to make decisions and predictions in real time. And we'll hear about one of these examples from one of our speakers. And then finally, the fourth type of interaction we mapped was all about applying AI behind the scenes. So how to optimize processes within collective intelligence in order to enable better matching of information to people or helping people, for example, in digital democracy platforms to find each other if they have similar interests so that they could join together and collaborate to achieve more. Normally at this stage in my talk, I would go to describe a couple of examples in the real world, but I'm going to defer to our other speakers who are going to be actually giving examples of their projects later after I finish. So to go on, you can also explore many other case studies that we've published online. But I'm going to continue about other strands of our research, which are actually looking at how collective intelligence methods can improve the technology that we're developing with AI. We've heard over recent years a lot of concern about historical biases and also structural inequality that's being hard-coded into algorithms. And this is a really important issue to pay attention to. The Gender Shades project on the slide is one that was led by Joy Bulamwini that helped to highlight how facial recognition systems are far less accurate for certain demographic groups, specifically women of color. And it's work like this and other incredible projects that are helping us to realize how these systems are limited and who they're actually benefiting and who is being left out, whether they're not being represented in data sets or they're absent from them entirely. But collective intelligence can help because at the principles of successful collective intelligence design, at the core of it is the need to involve a diversity of contributions and also to ensure that benefits are spread amongst those who are contributing to a project. And when we think about the AI lifecycle or the data pipeline, there are many different intervention points at which these principles can be integrated in order to improve the technology. It's not just about having more diverse data sets, but it's about involving more opinions and voices at every stage, from the planning to the monitoring and the use of these systems in the real world. And so we can start to see that AI and collective intelligence are very interwoven and mutually dependent. And that's why it's really important with these systems to really pay attention to questions of design to make sure they're as good as they can and should be. And in the report, we talk about a number of tensions that innovators might face when trying out these methods in the real world. And of course, it's not as simple as binary trade-offs. And I'm not going to have a chance to go into the details of everything on the slide now, but I hope we can start to get into these during the panel discussion. As part of our research at the Centre, we're also exploring what the future might look like if we start to see more examples of AI and collective intelligence. And today we published a series of stories that look at implementing these systems to improve our healthcare or to address issues of misinformation or enhance creativity. And you can find them on the Nesta website. We're also really interested in building a community of practice around this. So we support practitioners to carry out experiments that test out these ideas in the real world to make sure that we are making the most optimal design choices. And I'm going to now hand over to some of those incredible grantees and our other speaker as well from Pulse Lab, who are going to talk you through what it looks like when you have collective intelligence and AI combined in the real world.
Hi, I'm Rosenberg, a CEO of Unanimous AI, and over the last 5 years, we've developed a very different approach to AI called Swarm AI. And rather than using AI to replace human intelligence, we use AI to connect groups of people together into real-time systems modeled after natural swarms. And in scientific terms, we turn human groups connected over the internet into a swarm intelligence that can be significantly smarter than the individuals could be alone. So why swarms? It turns out that Mother Nature, through the process of evolution, has spent hundreds of millions of years working on this problem of collective intelligence. And this has been for social species that make decisions together in large groups. For example, flocks of birds, schools of fish, swarms of bees. Now, in these species, you have large groups. Each individual has a slightly different view of the world, different past experiences, even different temperaments. So how does nature harness and combine all of these views to make optimal decisions? Well, what nature does not do is nature does not take votes, conduct polls, run surveys. There's no survey monkey in nature. Nature also doesn't do post-processing on big data sets. There's no big data and machine learning in nature. What nature does instead is form systems, real-time systems where the groups push and pull on each other with feedback loops and converge on optimal solutions together. And that's what's called swarm intelligence. And so the question that inspired us to found Unanimous AI was simply this: if birds and bees and fish can get so much smarter by thinking together in swarms, why can't people do it? And it turns out that we can. If we connect people together into systems. So what you see here on the screen is an artificial swarm. It's about 100 people connected together over the internet in real time, moderated by AI algorithms and optimized for making forecasts and decisions. And what we've shown over the last 6 years or 5 years through lots of different studies is that it works, that human groups can get significantly smarter. So for example, last year we published a study with Stanford University showing that swarms of medical doctors, when connected together into swarms, could increase their diagnostic accuracy by over 30%. We also published a study last year with MIT showing that swarms of financial traders, when connected together in real time, could increase their forecasting accuracy by over 25%. And we have a new study that we recently did with Nesta showing that groups of voters with conflicting political views could prioritize objectives significantly more effectively as a swarm than by taking majority vote. So in short, we found the best way to amplify the collective intelligence of a human group isn't by aggregating the data, but by connecting groups of people together into a unified intelligence. And that is swarm AI.
Thanks, Lewis. And now we're going to hear from Yvonne McDermott Rees, who'll be telling us about how collective intelligence and AI can be combined for human rights.
Thanks, Alex. Thanks, everyone. Well, as people might be aware already, when war crimes and other serious mass human rights violations have happened in recent years, eyewitnesses are increasingly picking up their mobile phones and using them to record videos and images of these atrocities taking place. And our Nesta-funded project sought to examine what steps need to be put in place to ensure that this citizen evidence can be used to support legal accountability processes. There are a couple of challenges in this regard. The first is the volume of this kind of evidence and how to store and manage it. So in our experiment, we developed a new system. You can see in the bottom left-hand corner a screenshot of it in action for managing collections of open source and confidential evidence. So we developed a tool to preserve open source evidence in a way that will meet the chain of custody requirements that courts have. And then we integrated that tool with Uwazi, which is an evidence management software, to mean that evidence can be curated and organised with tags for evidence of the same incident. The second challenge is finding relevant evidence. So in our case, we wanted to search the entire archive of YouTube videos from the war in Yemen to find specific examples of cluster munitions, which are illegal. And our experiment partners in Yemeni archive developed a machine learning algorithm to detect cluster munitions in videos. You can see them in the slide in the top right-hand corner. This was actually really challenging because there wasn't a good pre-existing collection of videos to act as a ground truth sample. So we had to create our own using synthetic 3D imagery. You can see in the bottom corner there, the 3D imagery in action. And our experiment demonstrated how machine learning can assist human rights investigators in filtering these massive quantities of user-generated evidence to detect the most relevant photos or videos to their case. And we think these methods could be used in other contexts for journalism, history, academic research, and to find the best evidence from open sources. Our experiment also uncovered some of the barriers to collective intelligence in human rights, and these include concern around the security of the data and its admissibility in court. So by creating a secure, integrated evidence management system to include both open source and closed data, we were able to demonstrate how mixed masses of evidence can be taken together to prove the existence of mass human rights violations. As a result of this experiment, our project partners, GLAN, the Global Legal Action Network, were able to submit a dossier to the UK government showing how arms sold from the UK were used to carry out unlawful attacks in Yemen. And this project enabled us to combine the citizen evidence, collective intelligence and action, with evidence gathered locally from field investigators to draw insights on war crimes. So, we really look forward to hearing any questions you have about the project. Thank you.
Thanks a lot, Yvonne. And so finally, we'll hear from Dharani Burra from Lab Jakarta, who'll talk about their mixed methods approach to development.
Hey there, hello everyone from Jakarta. I'm Dharani, I'm a data scientist with Lab Jakarta. Firstly, thank you very much for the organizers for giving the lab an opportunity to present itself on this platform. Lab Jakarta is a data science, data innovation facility that is co-owned by the government of Indonesia and the United Nations Development Program. Our mandate is to use a combination of data science approaches and human-centered design principles to assist national and international governments to build data solutions across for challenges across those theme areas. My role in the lab is to improve the interpretability of machine learning and artificial intelligence approaches. I mean, highly complex machine learning AI approaches are kind of work like a black box. And my role is to, and we have started to realize that it's not, just machine learning and AI approaches cannot be the solution for everything, and that's where we are starting to rely on human intelligence combined with data science principles. I'll give an example of one particular project called, in the field of agriculture, where we wanted to use a combination of multiple big data sources, from high resolution satellite imagery to even administrative data, that is the census, to identify farming communities that have been consistently producing consistently faring very well across time. In any community, there are certain individuals who do better than the others. Right, and this approach of positive deviance, which is called positive deviance, where the people who do better are called deviants. In the traditional way of positive deviance approach, it would entail, a participatory approach where someone actually goes, a demographer goes into the community, looks at the community, understands who these individuals are, and then tries to understand the reason for deviance. Our hypothesis was that since we've got access to big data, which is in terms of like remote sensing and satellite imagery, it would be easier to identify these deviants, which is a very cumbersome process in the old positive deviance approach. Turns out that's not the case. Actually, we had to rely on human intelligence at every level, everything from defining what success is to understanding how do you define communities, to understand what are the measurement parameters, to even validate our findings. So so I'm happy to share a little more about this work in the panel discussion, and I'm really glad that I'm able to represent the lab on this platform. Thanks.
Thanks a lot. So now I'll hand over to Ravi, who will be moderating our discussion.
Thank you very much for those fantastic examples. When you look across them, in some cases, it's really very clear where the complementarity exists between humans and artificial intelligence. So in the example of Yemen, it's obvious that you cannot do what you're doing, Yvonne, in relation to prosecuting human rights violations without the raw human input that is then captured and synthesized. But in some other examples, like the radiology example, I think that Lewis can talk about, it's not clear to me where the complementarity sits between humans and machines, or how that is changing, and whether we're just in a temporary moment where humans and machines together are better, that may well actually be superseded by a moment where actually pure AI on its own is actually a better option. So, Lewis, could you perhaps comment on that? And I'll ask one or two others to comment on it as well.
Sure. So certainly in the field of radiology, there's been a lot of progress with straight artificial intelligence, with deep learning that can process large numbers of X-rays and then make accurate diagnoses. And in fact, it's The progress in the field of radiology has been so significant that radiologists are scared. They're scared about losing their jobs, losing their profession, because it looks like machine learning could just replace the entire field. And that actually was the inspiration for us to do an NSF-funded research project with Stanford University Medical School to say, hey, what happens if we take groups of doctors and connect them together into swarms? Can they take the title back for humans to be the most accurate forecasters? And what we found was that when you connect groups of people together, and these were small groups of radiologists, just 4 or 5 radiologists connected together by AI, they were able to match and even exceed the deep learning systems. And so that was interesting. But what was most interesting was that we discovered that the AI and the humans had different strengths, very different strengths. And so the AI was really, really good at making rapid, accurate diagnoses of cases that it had seen before, things that were similar, but really failed when it saw something unusual. Whereas the humans were really good at diagnosing things it had never seen before. The humans were able to basically extrapolate from their years and years of wisdom and experience and knowledge and training and see something totally new and make a more accurate diagnosis. And so ultimately what we found was that if we combined these two strengths, if we allowed the AI to diagnose cases that were very, very similar to things seen in the past, but allowed these human groups moderated by AI to diagnose cases that were unusual, the combination was more accurate, significantly more accurate than either by itself.
And Lewis, one of the things that you said interested me, which is that when it comes to diverse perspectives, swarm intelligence is very, very good at combining those diverse perspectives into something meaningful. And although we often say that diversity is good, diversity produces better results, I think as humans, we often struggle to actually synthesize and get the best out of the rich perspectives we have available to us. Can you just say a little bit more about how swarm AI really enables diversity and the full potential of it to be realized?
Yeah, so, and again, it goes back to nature. In the natural world, the only reason why swarms evolved was because you have these large populations of individuals that all have slightly different views of the world and have slightly different experiences and slightly different temperaments. If they all had the exact same knowledge and experience, you could just ask one of them and get the best decision. And so diversity is essentially the requirement for swarm intelligence. And what we found is that when we do that with human groups, especially groups that have diverse either backgrounds or experience or expertise, and we combine them with AI, the end result becomes significantly more accurate. And I can go back to a medical example. If you take a group of doctors who are, for example, doing treatment planning, and maybe that group of doctors is very diverse. It has an oncologist, it has a radiologist, it has an internist, it has a group of people who all have different backgrounds, different perspectives, they come at the problem differently. In a traditional setting, they'd sit around a room, maybe argue about it, and come up with a decision, and that decision might be influenced by politics, decision might be influenced by hierarchy. When we bring groups together as a swarm intelligence, there is no politics, there is no hierarchy, everybody's equal. And what we're doing is we're basically looking at their different levels of confidence and conviction and combining their insights to give the strongest possible combination of their views. And it turns out that it works. When we do that with diverse groups, whether it's medical, whether it's political, whether it's financial, we see groups converging on decisions that are significantly more accurate or significantly better representation of the population than traditional methods.
Just turning to Alex, this question about how you combine human and machine intelligence, COVID is a good example where you've got lots of different perspectives coming together in a room to try to make recommendations. Can you just say a little bit about the limits of AI in relation to COVID, but also the value of human and machine interaction?
Yeah, of course. So I guess it picks up a little bit on what Lewis has just been saying. It's been really interesting to follow the reports in the last couple of weeks and months about the failures of AI that are being exposed as a result of changes in behavior that have come on in response to COVID. So we see recommendation systems on platforms that are suddenly getting an influx of new subscribers who perhaps have different viewing patterns than the ones that they've been trained on, failing and becoming a lot less accurate, or their performance suffering from the kind of changes in the distribution of inputs. And we also see that there's inventory kind of changes and fraud detection mechanisms, which are really struggling to adapt in this dynamic situation. On the other hand, when it comes to some of the most successful responses, such as the mutual aid networks or the kind of DIY maker approaches, they are built on existing communities of innovators, which have been built over time for people who come together to work on a particular goal and who have a shared kind of discourse and understanding and shared tools to work on problems together. I mean, a great example of that is how we're seeing research being transformed over the last couple of months, and how many researchers have pivoted to try and apply their expertise in order to address questions of biology, but also questions of mental health and supply, and developing new solutions to actual treatments of COVID, and how introducing practices of open repositories and sharing of information and preprint publications have enabled us to make advances at a much quicker rate than we otherwise would have been able to do. And AI is struggling to keep up in that sense. So a lot of the systems that we might have applied, or we might have thought we could apply, they are suddenly struggling because the context has changed so dramatically that the training data that they were first trained on doesn't necessarily reflect the world as it is now. Of course, there are examples where there is a great collaboration or a combination of the two. One of my favorites is a forecasting project led by researchers at Carnegie Mellon University in the US. And they combined 3 different methods: 2 statistical models and predictive models that produce a nowcast and a forecast of the spread of COVID. And also they draw on crowd predictions, and they integrate all of those methods in order to produce their final forecast. And over the last 5 years, this is the group that has been most successful at predicting influenza-like illnesses in the US. So I think there's a real kind of interesting opportunity to see and test the limits of which parts of the problem we can rely on AI to help us solve, and where we really need these kind of established networks of people. And we're ultimately a social species. So I think that's the most exciting kind of part of how we can get even better at addressing problems together.
And Dharani, you talked a bit about real-world insights being crucial, and using human-centered design, for instance, to capture those perspectives. Can you just say a little bit more about how you see this relationship?
Yeah, I mean, just picking from what Alex said, that humans are complex, and they are, the way they think changes across space and time. Data and digital tools can't codify everything that humans are acting, right? So your phone cannot be a representation of who you are across space and time. So that's why it's extremely essential to have human intelligence, which is the non-codified bit that can complement with all the data crumbs from digital tools together to better understand complex system. So in our case, for example, in the example that I gave, rural communities, for whom we work most of the times, they are the most data scarce ecosystem. I mean, they don't release any data crumbs. They don't use phones like us. They are starting to use now, of course. So the thing is, we might get all these fancy high-resolution satellite imageries and start understanding what the communities are doing. But unless and until there's this ground intelligence from the local communities, which are data scarce currently, unless they are combined with this machine learning AI and big data sources, only then our solutions will become more sustainable, or not we'll just become like a fancy one-off innovations and then die off. That's been our experience, actually.
Great, and we'll give an interesting sketch where we're at now. Yvonne, I'm interested in turning to you now to talk about where is this going. So if you cast your mind 4 or 5 years ahead, in the context of human rights violations, where do you think we're going to get to?
Yes, where are things going in the next 5 years or so? The short answer is I'm not sure. Of course, we can hope that citizen-led evidence will have an increasing influence on accountability processes. We can see small pockets of that happening already, but just to pick up on something Louis said at the start, people are resistant to change, and the legal profession is no different. Courts address this kind of evidence with a sense of wariness, and I think some skepticism is to be expected and is to be welcomed. Actually, the danger of this going too far would be that we would see less reliable evidence seeping into court processes, which would be no good for anyone. So I think we can increasingly, especially I think in the post-COVID era where we have restrictions on travel, we can hope that citizen-led evidence will lead to a greater democratization of investigations. Investigations, I think, are going to increasingly move online using these open source platforms to find out what's really happening. We can see it in the US, for example, with attacks on protesters in Black Lives Matter protests, that people are using their mobile phone as a tool almost to protect themselves and to show what's happening. So that's my hope. It's not without challenges, and I think this is where we can look at AI and other machine learning tools that can be used to help filter the evidence that's the huge volumes of evidence that is posted out there. And then it's really about informing courts, informing judges, the legal profession about the value of this kind of evidence, about techniques around the verification of evidence, and upskilling really, so that the legal profession is ready to meet the challenges of open source evidence and to harness it for good.
So you see the main challenges being how the legal profession catches up and adapts its institutions. But I was going to ask you about things like deep fakes and the other big challenges to this actually working.
Yes, yeah. Deepfakes, I think, is a massive issue. I think it's challenging at a pretty fundamental level our trust in evidence. And we can see how deepfake narratives can be harnessed by, people who wish to deny the existence of this evidence. So almost invariably when, let's say, a video of an atrocity happening is shared widely online, the perpetrators, people associated with the perpetrators are out saying it's fake. But at the moment, deepfake technology isn't so advanced that, at the moment there are tools that we can use to figure out what are deepfakes. As that technology gets more advanced, then the techniques we use to figure out what's real and what's not, what's been doctored, we'll have to adapt to adjust to this and to figure out that. But I think it's a pretty fundamental challenge to this kind of evidence and to fact finding in general.
Thanks. And Lewis, can I ask you to comment on this future gazing, but can I actually ask you more about the immediate application first? Because one obvious thought in relation to swarm AI is whether the very different disciplines that are currently being used to predict COVID response and a second wave, whether we can use your techniques to improve the way in which our scientific advice is synthesized and interpreted. But then also perhaps I'd love you to talk more about political decision making in the longer term and how swarm AI can be applied there.
Yeah, so I mean, the underlying principle of swarm AI is that people are smart. And we shouldn't just throw people out and replace them with AI, which has really been the trend over the last few years. And people have been so excited about AI, they said, let's replace people with the ability to just process data. Now, COVID's a good example of something completely new. There is not historical data that tells us everything we need to know about COVID and how to respond. And so it's a perfect example of the type of problem where human knowledge, human wisdom, human intuition should be harnessed. And so swarm intelligence is a perfect way to combine the power of AI and humans to allow us to aggregate and harness and optimize that knowledge. And we see it not just in things as important as COVID, but also in just pretty mundane things throughout the business world. All across the business world, we've seen this push to replace human decisions with AI decisions. We work with lots of Fortune 500 companies, and they've been working to say, hey, can they replace their sales forecasting with just processing data? And what they've discovered over the last couple of years is that when they use historical data and AI to predict sales, what they're really doing is predicting last year's sales, because that's the data that they have. And they are starting to realize, hey, the people in their organization, whether it's and especially if it's a diverse group of people from sales, marketing, people from all different types of locations, if we combine those people into a swarm intelligence, and we then use AI to amplify their knowledge and wisdom, they can generate significantly more accurate sales forecasts, just like doctors can generate more accurate diagnoses.
And Dharani, it's kind of same question for you, really. What are you most excited about in the future in your world?
In our world, I'm really excited about the rural communities going digital, because that has been the most data scarce, ecosystem. We're getting prepared for it. Currently, as many of these examples have been shown, that most of the training data is biased towards people who have who are in urban areas and who use digital tools. But now with the rural communities, Indonesia is a very good example where mobile money is becoming a big thing, even in rural areas. So now we are going to start capturing very unique things, new things about rural communities that we would never have understood. It's just getting prepared for that and learning from experiences from what we've done in the past with the urban communities, for example.
And what's going to get in the way in realizing that potential?
Data access would be one issue, but that's a very that would be a relatively small challenge compared to bigger challenges like understanding of what success is, what sustainability is, and how these data sources that are there, how are they able to answer these questions. So there's a simpler problem and there's a more complex problem. The simpler problem is in terms of, say, digital tools and data access with like private sector companies, ride sharing data. But that is eventually going to get solved. But the real challenge would be then, what do you want to understand? What do you want to see? And whether the data sets that are available answer those questions.
Thank you. And Alex, in the final minute before we go over to Q&A, I know you've been doing some work on creativity and how collective intelligence and AI can actually foster new forms of creativity. Can you just say a little bit more about that, Hope?
Yeah, I think it's one of the most exciting new technologies out there. So in our research, we came across a system called Generative Design, which has been developed by Autodesk. And it's a generative AI system, which at the moment is mostly being applied at a kind of individual level to help designers to come up with new ideas for product design and product development. And I think that if we pivot slightly and look at the kind of success and collaborative cultures that exist within gaming communities and start to think about how we can integrate both generative design and collaborative creativity that we do see in game creation, we can think about how we might use those technologies to solve public problems. For example, in urban environments? How can we use that to involve more communities in urban planning and helping to stretch the imagination of what is possible that satisfies everyone's constraints, but also helps them to explore new ideas? I think it's this kind of idea of extending and transforming creativity, but also providing new capabilities for groups of people to develop shared mental models, which can then be manipulated and adapted, is really exciting, because at the moment we do that to make decisions anyway, but we do it at the individual level. So having the technology to allow us to do that, to make better things together, I think is incredibly exciting.
Thanks very much, Alex. And thank you very much to all of the speakers. I'm going to invite all the audience now to join us for a 30-minute Q&A for more discussion. Just to say, at Nesta, particularly at the Centre for Collective Intelligence Design, we're doing a lot of work about trends in AI innovation, how AI and collective intelligence can come together, and how we can build a better evidence base. And do join us for Nesta's AI Spotlight Week, the week beginning of the 15th of June, where we'll be bringing together all sorts of activities with special features and events. With that, thank you again for the speakers, and we'll see you over in a few minutes to take some questions for the next half an hour. Thank you very much.
Thank you. Thank you so much, Ravi. A big thank you again to Yvonne, Louis, Alex, and Dharani. It's such an interesting conversation, one that transcends sectors and industry. And if you're as excited to carry on the conversation, if you're logged in over on the platform, you can now move across with your to join the panel for a deeper dive into the questions and answer session, as Ravi mentioned. We'll be back at 3 p.m. for a fireside chat coming up, and the topic is going to be around research and collaboration. So we'll be hearing from Facebook AI. Please do join us online, join the conversation with our hashtag CogX 2020, get involved and meet your virtual attendees on the platform. I'm going to go and get a quick cuppa and be back at 3 o'clock, and hopefully I'll see you at the next session. Thank you all.
Want access to more CogX videos? Subscribe now for free at cogx.co.